Flappy Bird assignment. I'm going to assume you know how to get the Desmos. If not, just type in DESMOS into Google and it'll show up. Now you might have to go to Google Images and find a background of that game, Flappy Bird. If you're in our course, you can just download the predetermined file. So to import that image, to put it into the graphing calculator Desmos, we go to the button that says Add Item here. It's a plus sign, okay? And if you go all the way down, you can put an image in. So we're going to click the image, and it's going to take me to where I've stored the file. So here's my Flappy Bird picture. So this is the picture I want to import. So I put it in, and then I can resize it. Okay. Now read your assignment carefully. For some of the assignments in our course, I want one to be above, and then I want you to put a duplicate image. Bring it in again. Another image similar below the x-axis. It depends on what the requirements are, so make sure you read that. But the basics of it. So here it is, and we have our bird, okay, and we want to get the bird through, obviously through the course. Now, depending on what functions it was told to you in the assignment, you'll have to use that type of function. For this one, I'm going to use a quadratic function. And I'm going to specifically use the vertex form because that's usually easiest to graph in. So if you remember vertex form, is ax minus h to the power of 2 plus a k value. You may use different variables. So what's neat about Desmos is I can put sliders in for those variables. Okay, so the a value clearly flips our quadratic. It also stretches and compresses it. The h value will move it left and right. Okay, and the k value moves it up and down. And here we go. I've already lined it with the bird. Now, if we're using gravity, and if you ever played this game before, we're clearly going to be using a negative a value. So I'm going to kind of flip it down. And here, this looks really good. The bird is kind of making its first jump. Okay, so if it makes its first jump, maybe to here, and then I want to start the next parabola at that point. Okay, well, I'm going to have to cut this one. So one of the ways I can fill this in is I can take my values. A was negative 0.2, so I can write that in. 0.2. My h value was negative 5.7. So because it's subtracting a negative in our brackets, actually the same as writing positive 5.7. I said 7.7, but 5.7. And the k value is negative 0.3. So negative 0.3. Here we go. Great. So here's our quadratic. Now I want to make it look like it's doing the bird's trajectory. So I want to use a domain to kind of cut this off. And the bird kind of starts at 5, yeah, maybe 5.3 works out. And I want to stop it somewhere about negative 4.2. So it's at, sorry, negative 5.3. So when I click in the line, you get a type of keyboard popping up. And you got to go to the button that says ABC. And that'll take us to curly brackets. We need to put curly brackets if we're going to set a domain to something. So I click on these curly brackets, and it sets it up here at the end. So I take the value farthest to the left here, and I want it to be negative 5.4. So negative 5.4. And now if you noticed, we've got a warning sign. It says I don't understand this. This is because I haven't quite finished what I need to write. I need it to be less than and equal to the value of x. And once I've done that, it's cut off the parabola to the left of negative 5.4. So it looks like it's the trajectory of the bird. The bird is coming down. And we want that trajectory to stop at, negative maybe 2.4. So I need to continue. I needed to say x is less than or equal to negative 2.4. And then once I've done that, you'll see it's cut off the trajectory of the bird. And then I would just put in another quadratic to jump through here, 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 here. And you can use as many or as few as you like. Okay. Now your teacher might ask you to, or the assignments might ask you to change the quadratic. This one's in vertex form. Maybe it wants you to have it in standard form, or maybe it wants you to have in factor form. So you may have to do that. I'll quickly jump to a note page so just to talk about how we do that. And so I quickly written out, here was our vertex form that we originally wrote it in. I quickly converted it to standard form. If you're unsure how to do that, you might want to watch some of the videos about how to go from a vertex to standard form. There's many different ways. And then there's also factor form. Now you notice I haven't written anything in, and there's a reason, because this one actually doesn't have any x-intercepts. We'll quickly go back into Desmos here, and I've already typed in our standard form. If you notice, the standard form overlaps the vertex form, which means they must be converted correctly because they're the exact same one. I can't put a vector form because this one actually doesn't have any x-intercepts. So if your project asks you to have x-intercepts, you have to make sure that your image is above the x-axis, or that your parabola would be going the other way so that it'll cross those x-intercepts.